Alright, hello everyone, welcome back to another video. Today we are going to be going over how to derive a cubic equation for z right here out of the van der Waals equation of state. So we're going to be doing some changes and transformations of this equation in order to get another equation out of z in terms of like z cubed, z squared, z, and a constant. So that's going to be a cubic equation for z right there. And yeah. As you can see here, we have our van der Waals equation of state with a few changes right here. We have, instead of the normal right side of the equation, we have a over v plus epsilon times b, and then that's multiplied by v plus alpha times b. Normally, we would not have this right here and this right here, because in the normal circumstances, you use the van der Waals equation. These epsilon and alpha, those would be equal to 0. But in the circumstances we're going to be using it in today, they're not going to be equal to 0, so we do have to include these two parameters in there. And over here on the left side, we have our equation for the compressibility factor z right there. That is equal to the pressure times volume over the specific gas constant times the temperature. And yeah, we are going to be making some transformations over here. And the first thing we want to do is we want to set z equal to this equation. And how we're going to do that is we're going to be multiplying this by v over RT, alright? So as you can see here, we already have pressure on this side of the equation. And to get that equal to z, all we have to do is multiply that by v over RT. Because as you can see here, z is equal to pv over RT. Alright, so we're going to go ahead and multiply both sides by v over RT right here. Alright, that's going to give us z, which is going to be equal to pv over RT, right? And then we're going to go ahead. These RTs right here are going to cancel out, and the v is going to go on top, so that's going to become v over v minus b, right? And then on this side, we're going to have minus av, and then we're going to have RT v plus epsilon b, and then that's going to be multiplied by v plus alpha b, as you can see here. Alright, so now we have our equation set equal to z right here. And we got a lot of v's over here, and we're not going to want all of those in our equation. So we're going to go ahead and multiply both sides by 1 over v, just so we can cancel some of those out right there, alright? And when we do that, we're going to get 1 over 1 minus bv. And then these v's are going to cancel out. Don't want that minus sign so big, so we're just going to get an a right here. Then we're going to get vrt. V is going to cancel out right here again, so we're going to get 1 plus epsilon b over v. And then 1 plus alpha b over v, right? Alright, there we go. Now for the next step, we are going to manipulate this equation so that we solve for v, alright? And to do that, we're going to multiply the RT over and then divide by p, right? So we're going to get v is equal to z RT. We're going to divide that by the pressure. And we're going to go ahead and substitute this expression right here for all of our v's in this equation. So we're going to go ahead, bring that over, and substitute all the v's. Alright, so we're going to get 1 over 1 minus, and now we got to flip it here, so it's going to be pb over zrt. And that's going to be equal to, alright, so that is going to give us zr squared times t squared. And then over here, we're going to get 1 plus peb over zrt. And that is going to be multiplied by 1 plus sigma. Get the p out front. P times sigma b over zrt. There we go. And as you can see here, we do have a lot of these PB over RT in our expressions here. So we are going to create something. We're going to create a constant here to simplify this down, so we can just plug that in for all of these PB over T's. And that is going to be beta over here. Beta is equal to PB over RT. So we're going to go ahead and plug that in for all those PB over RTs. So we're going to get 1 over 1 minus beta over z is equal to a over z r squared over t squared, and that's going to be equal to 1 plus epsilon beta, excuse me, over z. That's going to be multiplied by 1 plus sigma beta over z. There we go. And that is all equal to z. Alright, so now what we're going to want to do is we're going to want to multiply everything by 1 over z, so we can set this equal to 1. So we're going to go ahead and multiply both sides by 1 over z. That's going to give us 1. Alright, so we did make a few mistakes in the last recording. First of all, I just wanted to make sure that we knew that beta over here is equal to PB over RT. I had that written down as a P earlier. This is supposed to be R right here. And secondly, we do need to add pressure to the numerator over here. That is because when we were plugging in the volume right here, we had that volume is equal to z RT over P. We did account for the RT right here in the R squared T squared, but we did forget to bring the pressure up to the numerator. Since you are dividing a fraction right here, the denominator is going to be going up top, so we do need to put pressure up top right there. And so now we can continue on with what we were doing. We are dividing everything by z, or multiplying it by 1 over z. So we can set this equal to 1. So that is going to give us 1 over z minus beta. And we're going to subtract that. We're going to make this over here into its own fraction. That's going to be a times pressure over r squared times t squared. Right? And then that is going to be multiplied. Get some brackets going on. Alright, so that's going to be equal to 1 over, then we're going to have z plus epsilon beta, and that's going to be multiplied by z plus sigma beta, right there. Alright, and now we're going to be making a substitution, another substitution, and we're going to be using Q for that one. And Q is going to be equal to... Alright, so this second expression that we're going to be using for this equation is going to be Q. And that is going to be equal to A over B RT. And if you take a look here through our equation, there are no A over B RT, so right now there is nowhere where we can add this into our equation. But what we can go ahead and do is we can take this expression and we can separate that out a little bit. So we're going to get AP over R squared times T squared. And we can separate that out into A over RT times P over RT. And what we can go ahead and do is we can multiply this B over, and we can get QB is equal to A over RT, alright? And as you can see here, we have an A over RT, so we can go ahead and sub that in for QB. So you'll get QB times P over RT, right? And as you can see here, our beta up here is PB over RT, which we do have here. We have a PB over RT right there. So we can go ahead and say this is equal to Q times beta right here. And yeah, we can go ahead and sub that in right here. So we're going to get 1 is equal to 1 over z minus beta, and that's going to be subtracted. We're going to substitute q beta in for this, and that's just going to go in the numerator right there. So we'll get q, make that a q, kind of looks like an a right there. Q beta over z plus epsilon beta times z plus sigma beta. And yeah, there we have it. And the next step that we're going to be doing is we're going to be multiplying the whole equation by all of the denominators. So we're going to be multiplying it by z minus b, z plus epsilon times beta, and z plus sigma times beta. So we're going to be going ahead, multiplying that through. And we'll go ahead and erase this and erase all we have up here so we can make some room. There we go. And we'll just rewrite this equation up top and multiply by all of the denominators. Leave the equation so that we know what to write. Alright, let's go ahead and rewrite this up top. Get some more off of up here. Alright, so we got 1 is equal to 1 over z minus beta minus q beta over z plus epsilon times beta times z plus sigma times beta. Alrighty, and we're going to go ahead and multiply both sides by these denominators like I said earlier. So it's going to be z minus b over z plus epsilon beta. Squeeze this in there. This side of the equation is going to be really easy. It's just going to be all of these denominators right here since we're just multiplying it by 1. Go ahead and do the same thing on this side over here. Z minus beta times z plus epsilon beta times z plus sigma beta right there. Running out of room. It's alright. So we'll get, basically, this just drops down right here. We'll get z minus b, z plus epsilon beta, z plus sigma beta, and that is going to be all equal to this. So the z minus b's are going to cancel right here. So on the left side, it's just going to be z plus epsilon beta. That's going to be multiplied by z plus sigma beta. And then over here, the z plus epsilon beta and the z plus alpha beta, or not alpha, sigma beta, are going to cancel out with that. So it's just going to be q beta times z minus b. So we are going to get over here. Let me see here. These should not be added. Those should be getting multiplied right there. Sorry about that. That is going to be minus, in parentheses, q beta times z minus b right there. And yeah, from there we'll just go ahead and multiply these expressions out. Get everything multiplied out so that we have all of the individual factors going on, and then we'll just go ahead and add and subtract them. Alright, so what we're going to go ahead and do now is we're going to go ahead and multiply these two groups together, and then we're also going to multiply these groups together and factor this out right here. Alright, so before we do that, I did want to make sure I wrote this down as an English B. This is supposed to be a beta right here and right here. We do want to make sure that is beta. That's going to be important. We don't want to mess that up. Alright, so we're going to go ahead and start factoring all this out. So we're going to get a z minus beta. We're going to leave that for now and just focus on these two. We're going to get z squared plus z epsilon beta plus z sigma beta. And then we're going to get here an epsilon sigma beta squared right there. That's all going to be multiplied together. And since these right here are the same thing as these right here, it's going to be the exact same thing as this over on this side. So we can just go ahead and copy that over. We're going to get z squared plus z epsilon beta plus z sigma beta plus epsilon sigma beta squared. Alright, there we go. Now we're going to go ahead and factor these out right here. So we're going to get minus in parentheses, it's going to be zq beta minus, that's actually going to turn into a, no, it's still minus, never mind. That's going to be a q beta squared right there. There we go. Alright, so the next thing we're going to want to do here is we're going to want to bring everything over onto this side, and we're going to want to factor these out together. So we're going to get a, go ahead and factor the z out to all of them first. We're going to get a z cubed plus z squared epsilon beta plus z squared sigma beta. Then we'll get z epsilon sigma beta squared. Now we'll go ahead and factor out the negative beta to all of these expressions over here. So we'll get a minus z squared epsilon beta, and then a minus z epsilon beta squared, and then minus z sigma beta squared, and we'll go ahead and get a epsilon sigma beta cubed right there. And then we'll go ahead and subtract these over to the other side. So that's going to be a negative z squared, a negative z epsilon beta, negative z sigma beta, negative epsilon sigma beta squared. And then that is going to be subtraction, so that's going to be added over actually. So that's going to be plus zq beta, running out of room right here. That's going to turn into a plus sign, which means it's going to be subtracted over. So that is going to be minus q beta squared. Hopefully you can read that right there. That is a minus q beta squared right there. And that is all going to be equal to 0. Alright, so now we can go ahead and factor out all the like terms. So we only have one z cubed, so we'll get that going, z cubed. And then we'll factor out all the z squareds from everything. Alright, so we'll get an epsilon beta plus a sigma beta. Go ahead and get some parentheses going on that. Squared epsilon beta, like so. And then we got another z squared over here, so that's going to be a minus beta. Let's see, do we have any more? Yep, we got a minus 1 right there. And that looks like it does it for our z squared terms. Now we'll go ahead and do all of these z terms. Alright, so we got an epsilon sigma beta squared right there. Let's see, do we have any more? Minus an epsilon beta squared minus sigma beta squared. Let's see here. Any more? Minus epsilon beta minus sigma beta plus q beta. And that looks like it wraps it up for our z terms. So now all we have left is our constant. So we're going to go through and search for everything that does not have a z in it, which we have right here, and then right here, and right here. So we'll go ahead and try and squeeze that in right here. So we got an epsilon sigma beta cubed. And then right here we have minus epsilon sigma beta squared, and then right here we have a negative q beta squared. Sorry about this, running out of room. I don't have the smallest, most nimble handwriting in the world, so you're going to have to go off to the side. But if you can't read that, starting right here, it says minus epsilon sigma beta cubed minus epsilon sigma beta squared, and then minus qb squared. And that is all going to be equal to 0 right here. And there you have it. That is our cubic equation for z that we got from the van der Waals equation of state and the compressibility factor. This is our answer right here. As you can see, we have a z cubed, z squared, z, and a constant right here, making it a cubic equation. And yeah, that is our answer right there. Cleaned up about as much as you can possibly get it right there. And yeah, that's going to do it for today's video. Make sure to smash like and subscribe, and have a good one.